This section is the next one. We're still jumping around a little bit. We're going to talk about 3-4 equations of lines. Okay. First, before I do that, kind of your brain teaser for the day, let's look at this. There's a clerk at the butcher, there's a clerk at the butcher shop. It's 5 feet, 10 inches tall, and he has size 13 shoes. How much does he weigh? Take a second. I think he weighs meat because he's a butcher. Yeah. Good, right? All right. Now that you're there. All right. So the two things we're talking about today, one is slope-intercept form. Okay. We have to know what slope-intercept form is. That's y equals mx plus b. Remember all those awesome videos we watched last year? Y equals mx plus b. Okay. Slope, y equals, yes, that was the best song. That was my favorite. I'm impressed you guys remembered that. Two things in slope-intercept form to write the equation. You need the slope and you need this b variable, which we call the y-intercept. That's where it crosses the y-axis, right? You need those two things. The other thing we have is called point-slope form. When you're given a point and when you're given a slope, you can write an equation in point-slope form by plugging in the y-coordinate, the slope, and the x-coordinate. Okay? You can go from point-slope form to slope-intercept form by distributing the slope and moving this to the other side of the equation. There's another way you can do that also, though. We'll show you that. But we have slope-intercept form, point-and-slope form. These are the two things we're talking about today. For example, this says write an equation in slope-intercept form of a line which has a slope of 6 and a y-intercept of -3. So again, those are the two things I need to write an equation in slope-intercept form. I need a slope and I need a y-intercept. Those are the two things I need to plug in. So what am I going to plug in for m? 6, because that's my slope. What am I going to plug in for b? -3. That's my equation. Right? So when they give you both, it's very straightforward. You plug in the slope for m, you plug in the y-intercept for b. If I was to graph this, I would go at -3 on the y-axis. I'd then go up 6 and over to the right 1. Right? Because we can write that as 6 over 1, rise over run. If I was, b is the y-intercept. Yep. B is the y-intercept. M is the slope. Okay. So when they give you both like that, you just have to plug them in. Another one here, if I had a slope of -1 and a y-intercept of 4, which of these would be my equations in slope-intercept form? If I had a slope of -1 and a y-intercept of +4, which of those is the slope-intercept form of that equation? Yeah, Karen. Okay, good. Yeah, it is D. Good, right? You don't have to write the -1 in front of the x, but the -x is the same thing. -1x plus 4. If I was to graph it, I'd go to +4 on the y-axis, down 1 and to the right 1, down 1 to the right 1. Okay. So sometimes, though, well, this says write it in point-slope form. I have a point. My point's -10, 8. I have a slope, -3/5. Write it in point-slope form. Okay. Well, point-slope form is this. Okay. And I plug in three things. I plug in my y-coordinate, my x-coordinate, and my slope. Okay. To write it in point-slope form. So it's going to be y -8, because remember this is my x-coordinate, and that's my y-coordinate. The x-coordinate always comes first. Y -8 equals my slope, which is -3/5. X minus the x-coordinate. Now it's minus -10. So what should I do to simplify that? Yeah, make that a plus. Yeah. So this would be my point-slope form, given this point and this slope. I plug in my slope there, my y-coordinate, my x-coordinate. Okay. If I wanted to go to slope-intercept form, I'll show you another way to do it too. If I wanted to go to slope-intercept form, I didn't ask you to, but you would distribute that to get rid of the parentheses, and then you would add 8 to both sides to get it in y equals mx plus b form. But it didn't ask you to do that, so you don't have to do that. Okay. So that's point-slope form. So again, looking at this one, if I have a slope of 1/3 through the point 6, -3, which of those is the point-slope form of that equation? 6, -3, slope of 1/3. Yeah, Joe. Yeah, it's A, right? Sorry. Oh, because that minus, that's why. Because I want y minus -3. Minus a negative means it's +3 equals m parentheses x minus 6, my x-coordinate. I get 6 there. That's a point-slope form equation. You have a point, you have a slope, you just plug those in. Now sometimes, and I'm going to write this a little bigger here so we can see it, this says write in slope-intercept form, but all it gives you is this, 4, 9, and negative 2, 0. Remember in slope-intercept form, y equals mx plus b, you need two things to write the equation. You need the slope and you need the y-intercept. It didn't give me either of those things in this problem, right? It just gave me 2 points. The earlier problems, it gave me both. It gave me slope, it gave me a y-intercept. So how do you write an equation of a line where you only get 2 points? You need to find both of those things yourself. The first thing we can do is we can find the slope, okay? We can find the slope between these 2 points. How do you find the slope between 2 points? Remember what that? Yeah, it's that slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember we call that slope formula. Take the second y coordinate minus the first, divided by the second x coordinate minus the first. So if I just label these the first x, the first y, the second x, the second y. Again, doesn't matter. If I were to label this the first, second x, second y, and this the first x, the first y, I'd get the same thing. But to find the slope between there, I would take 0 minus 9 divided by negative 2 minus 4. That's negative 9 over negative 6. Well, negative over negative becomes a positive. And 9 over 6, both of those things are divisible by 3. That can become 3 over 2. So my slope between these 2 points is 3 over 2. I have my m. The only thing I need now is to find this b. Okay? Because once I have the b, I have m and b, I can write the equation. To do that, if I go back to the equation y equals mx plus b, I can plug in a y, an m, and an x and solve for b. If I plug in a y coordinate, my slope, which was 3/2, and an x, okay, then I can solve for the missing variable b. I could pick this for my x and y, or I could pick this for my x and y. It doesn't matter. Okay? I can pick either one and plug those in for y, x, and m and solve for b. Okay? So I'm going to erase this work right here. Everybody okay with this part so far? I have my slope is m, okay, or my slope is 3/2. So let's do that. Let's say I'm going to pick 4, 9. For no reason. I'm just picking that one because they're both positive. Okay? I'm going to plug in 9 for y. 3 over 2 is my m. And 4 for x plus b. And y equals mx plus b. I plugged in my y coordinate, my m, my x coordinate. Let's solve this equation for b, because that's the only other thing I need to write my slope-intercept form. Well, 3/2 times 4. Remember, you just multiply fractions straight across. 3 times 4 is 12. 2 times 1 is 2. So 12 over 2 is 6. And finally, I need to solve for b, so I need to move that positive 6 to the other side of the equal sign. So I will subtract it. And I get b equals 3. So I have my y-intercept. I have my slope. So I can write the equation, which would be y equals 3 over 2x plus 3. That would be the slope-intercept form that goes through these 2 points. Okay. Y equals 3 over 2x plus 3. I had to find the slope first using slope formula, and then I plugged in a y, m, and x to find b. Okay. Any questions with this particular example? Yes? If you're graphing, you could put in the points and then draw it. You could. The problem with that is your y-intercept, if your ruler gets off a little bit or something, your y-intercept, it may look like it's maybe at like 2.5 instead of 3. Yeah, you could do that, though. You should get y-intercept of 3 and up 3 over 2. Yeah, that's a good point. You could do that, too. Okay. But sometimes if you get like huge graphs, it'd probably be quicker to do this one. Question, if I use this, I'd plug in this for x, right? I would have plugged in it here. I would have plugged in this for y. I would have got 0 equals 3 over 2 times negative 2. Well, that's going to become negative 3. Then when I add 3 to both sides, 0 plus 3, I would get the same thing. Okay, good question. Yeah, you can pick either one. You should be able to get the same answer either one you pick. Good. So go ahead on a scratch sheet of paper. And again, if you need one, you can borrow one of mine up there, because this is a very likely quiz question. I want you to write the slope-intercept form between those 2 points. I'll give you a couple minutes to try that. I'll write them bigger here again so you can see them a little more clearly. Between 3, 2 and 6, 8. I would like the slope-intercept form between those 2 points. I'll give you a minute or two to try that. Check your answers with those up there. So a few of you have it or are close. Now they don't, again, in y equals mx plus b, you need a slope, which is m. You need a b, which is the y-intercept. So it doesn't give me the slope, so I use slope formula. I take the second y minus the first, divided by the second x minus the first. That's 6 over 3. So the slope is 2. I have my m. Now all I have to do is find b. So to do that, I can go back to y equals mx plus b. I can plug in, let's say I'm going to pick this pair of points. You could pick either one. 2, I plug in for y. 2, I plug in for x, because that's my, or m. 3, I plug in for x, because that's the x coordinate, plus b. 2 times 3 is 6. Solve for b, move that 6 to the other side. 2 minus 6, negative 4 equals b. So now I have my y-intercept, I have my slope, I can write the equation. Y equals 2x minus 4, which is c. How did I get this part? So the x coordinate I just took from this. I took that. 3 is the x coordinate, 2 is the y coordinate. I plugged in, and y equals mx plus b. I plugged in there for x and there for y. To solve for b, because that's the other missing piece I have. All right? So also you could have to apply what we did last class. So if I look at this line here, first, what's the slope of this line right here, this equation, y equals negative 1 of x plus 1? What's the slope?
1.
The number in front of the x, remember, negative 1/2. Okay, this is the slope, that's the y-intercept. So if I said write an equation in slope-intercept form of a line that goes through 1, 7 and is perpendicular to this line. Okay. I want one that's perpendicular to this line. Now remember, parallel lines have the same slopes. What's the relationship between slopes and perpendicular lines? They're opposite reciprocals, right? So if I want a perpendicular to this slope, what's the opposite reciprocal, negative 1/2? No? Yes, positive 2. All right, positive 2. I flip the fraction, it becomes its opposite. So that means I'm going to use this piece of information to write my slope-intercept form. I have my m, I need the b. Right? So in y equals mx plus b, I'm going to plug in y, m, and x to find b. Okay. Well, y is 7, m is 2, x is 1, 2 times 1 is 2. Move that 2 to the other side by subtracting it. 7 minus 2, b is 5. So I have my slope, I have my y-intercept, I can write the equation. Y equals 2x plus 5. So just remember, if I ask for a parallel line, you're going to use the same slope as the equation I give you. If it's a perpendicular line, you're going to use the opposite reciprocal slope of the line I give you. Okay? So that's a little bit of what we did last time. Still write the equation in slope-intercept form. You need a slope, you need a y-intercept every time. And just real briefly, we're going to look at these. So some kind of applications that you could represent in a slope equation. This says this apartment complex, it's $525 per month, and you have to pay $750 flat fee in maintenance costs per year. Write an equation, part A, write an equation to represent the total cost A for R months of rent. I don't know why they use R for months of rent, but for example, that's $525 for every R month, plus I pay $750, right? This is the equation. A is the total cost. If it was 1 month, I'd take 525 times 1, plus I still get charged at $750. If it was 2 months, I'd take 525 times 2, plus the $750. Okay? So this is set up like a slope-intercept form equation. I could graph this. That's my y-intercept. My slope's 525. Okay. Now the other one says there's another apartment complex that has $600 per month plus a $200 fee, okay, for a year. And I can represent it with this equation. The question is, which of these is more expensive after 12 months? Okay. Which of these is more expensive after 12 months? How can I find that now that I have these two equations? I want to find which charges more after 12 months. Yeah. Yeah, just plug 12 in for R. Right? Does anybody have a calculator out in front of them? If you could do 525 times 12 plus 750. $525 times 12 plus 650 or 750. One is 7,050 for the whole year. What about apartment 2 if we plug in 12 there? Yeah, what is it? 7,200. Okay. So that means apartment 1 is cheaper for the whole year, even though the maintenance cost is a lot more. Okay, after 12 months, it's less expensive than the second one. So we can use these equations that are in slope-intercept form to solve other problems like this. Any questions there? Similar thing here, a car rental company is $25 per day plus a $100 deposit. Which of those equations would represent the total cost? If it's a flat fee of $100 plus $25 every day, which of those equations would represent that situation? Yeah, right. $25 every day. So if it was 5 days, I'd plug in 5 for D, take that times 25, plus I'm charged that $100. Okay. All right, we're going to do a little iPad activity here.